everyone. Today we are going to understand the capacity modes in DynamoDB, which is RCU or WCU. So DynamoDB provides two types of capacity modes. One is provision, you could say manual, and on demand is basically automatic, managed by AWS internally. Based on your workload, it will keep on adding the RCUs or the capacity. We'll come to RCUs and WCUs. Now, so in the provision capacity mode, once you decide the RCU and the WCU, which is the read capacity units and write capacity units, you are charged for everything, even though you use it, if you use it or not. So this is best for the predictable workload. You can use auto scaling as well on top of this. So just keep this in mind. In provision, right? Provision RCU plus RCU, you pay for everything. And on demand, it is basically automatic, handled internally, and you pay for the request that you have done. Now coming to read capacity units. So read is basically when we are retrieving the data. So how do you calculate what it should be a read capacity units? So it determines how much data you can read per second. Just keep this in mind. How much data you can read per second. Your capacity units will decide how much data you can read per second. And it depends on two things. One is the item size or the row size and the consistency of read. So whether you want strongly consistent read, eventually consistent read, or a transactional read. Based on this, the capacity units or the charges basically changes. So let's understand the calculation of RCU with an example. Let me So this is the formula for calculating the read capacity units in DynamoDB. So you can break it up in this way. There is a common formula where you apply this, the item size. Whatever is the item size of your application, and you divide it by 4 KB. In read, you divide it by 4 KB, and you apply ceiling on top of that. So when we say ceiling, you will understand it differently. So in case of, say, there is 3 by 2, right? It would come to 1.5. Then ceiling would be 2. So that's the, so it takes the higher number or higher number basically. So this is the common formula, you could say the, and then in the eventual, you apply this C1 or the common formula. And in case of eventual reads, so when we say eventual consistent, it means we can expect failure. In case of strongly consistent, basically we will receive the consistent data. And transactional is, it will follow all the asset properties. So here, in the case of eventual, you multiply it by 0.5, whatever is the value that you get in C1. And then in strong, you multiply it by 1, and in transactional, you multiply by 2. So if you remember this formula, and just remember that eventual, strong, and transactional, you multiply it by 0.5, 1, and 2. It becomes easier. So suppose there is this example now. Your application has item size as 6 KB, and the 6 KB items will have these different types of reads. Say one is 100 strong reads, then we have 200 eventual reads, and 50 transaction reads. So how would you calculate the read capacity units for your application? So first formula is this one. So here I apply scaling. My item size is 6 KB. So here I apply 6 divided by 4. I get 1.5, and after scaling it will be 2. And once I get this one, then this is the formula. For eventual, 2 into 0.5 is 1. And how many reads? 200. So total is 200 RCU for eventual. For strong, it is 2 into 1. And then how many reads? 100. 2 into 100 is 200. And for transactional, it is 2 into 2. Basically, 2 is your right T1, and this is a factor for transaction. 2 into 2, and when you multiply 4 into 50, 50 transaction rate, you get 200. So first you, based on the item size, you find the C1, which is your item size divided by 4 KB. So just keep this in mind. In reads, it is 4 KB. 4 KB is the factor. And for eventual strong and transactional rates, this would be the factors 0.5, 1, and 2, constant temperature. And in total, you will get 600 versus. That is the capacity that you would need for your application. And moving on to the write capacity. So how much data you can write per second? So this is for write, and it has two types. One is standard write and transaction write. Where standard writes consumes up to 2 WCUs. So it will be double this formula, whatever you are getting, item size divided by 1 KB. So in case of WCUs, so if you look at the common formula, we are dividing item size by 1 KB. That's the difference in write. In read it was 4 KB. In write it was 1 KB. You can write this formula down, and then in standard writes, we multiply it by 1, and in transaction multiply by 2. Now let's take this example. Say your item size is 2.5 KB, and standard writes are 150 and transaction are 50. How would you calculate? So first is C1. Take this 2.5 divided by 1 KB. So 1 divided by 2.5 is 2.5. If I apply ceiling, then it becomes 3. So you get the first part. Now you just multiply 3 into 1 is 3. And then 3. And what is the number of writes? 150. So it becomes 450. And in case of transactions, it is 3 into 2 is 6. So 3 came from C1 and 2 is the factor. So 3 into 2 is 6. And then we have 50 transaction rights 300. So the total WCU is 750 WCU. So just keep this formula in mind. How we can define the provision capacity mode. So if you go inside this table, there is this read write capacity. By default, it is on demand because I have not selected provision. But I can change it. If you go here, these two options, on demand and provision. So here you can set maximum read request units, write units. In my case, it was 600, right? And then this was 750. So I can set it in this way. Once I set this, Then the provision capacity, sorry, I need to put it here. This was on demand. In on demand also you can put a maximum limit. But in case of provision, so here you provide. If there is a the provision capacity that I provided is 600 and I want to do auto scaling on top of that, and I have this option. So here you can provide minimum capacity units, say 600, say maximum 800. And when should the auto scaling trigger? Only 70% utilization of the minimum capacity. And initial provision capacity, say let's keep this as 500. Sorry, because minimum is it, so this is 650. This is how you can set the auto scaling as well. And if you don't set auto scaling, then you just provide the provision capacity unit. And we have already seen how to calculate the provision capacity units. I'm not changing anything here for now, but this is an option that you can do. And so suppose if I create a table, if I go in customize settings, here there is a capacity calculator. So here you can provide like my item size 6 KB, my item read per second, the eventual consistent or standard consistent, it is, what was that, 100? Let's make it 200. This is 200. It has calculated the capacity unit for both read and write. So write is 20. Here there are three options, eventually, strong consistent, transaction, and here there is standard and transaction. And then the estimated cost. Use that estimated cost. This is a very big number. And in provision mode, so this is the capacity calculator. How much capacity do we need? We won't need that big number. Let's put it 10 for now. We will get $30 per month. And then provision capacity, we can just add here. What is the capacity? Using the auto scaling and auto stuff. And few more important points. So in case you provision RCU WCU and there is no auto scaling, right? Then you would get this exception, provision throughput exceeded exception. And what could be the reasons? Obviously, hot case or single partition is being read many times. A very hot partition. And obviously, the item size is very big. And solutions could be exponential back off. So this is already part of SDK. And you should distribute the partition as much as possible. So actually, key thing there. And if there is an RCU issue, we can use DynamoDB accelerator or DAX. This is like a caching layer on top of the DynamoDB. So instead of we continuously fetching data from the DynamoDB, using the RCU, we can use the caching layer. Just like Redis layer. So DynamoDB also provides a caching layer, which is called DynamoDB accelerator. This was all about the capacity nodes. Thank you for that.